Welcome for a math lesson. We're going to study three-dimensional geometry. Number 21 of this paper. A question which says that the figure below shows a cuboid A, B, C, D, E, F, G, H with AB as 8 centimeters, BC 6, CH 5 centimeters. So the first question which we are told to find in this question is to one decimal place the length of BE. The length of BE. We have a lot of space around the figure, therefore I'm going to use the space here instead of where the question has been written. Therefore, the length of BE, remember BE is a line which is inside the cuboid. We can join the two vertices to get BE. So that is the length BE. Remember, B is on the front face, but E is a vertex of the face at the back. Therefore, for us to get BE, remember we already know DE because CH is known to be 5. Therefore, this is also going to be 5 centimeters. So DE is 5 centimeters. And the other length we need is length DB. The length at the base here. The length at the base there. So we can get the length at the base because we have 6 here and we have 8 here. According to Pythagoras' theorem, the length is going to be 10 centimeters. So length DB is 10 centimeters and DE is 5 centimeters. So we can apply Pythagoras' theorem at that point for us to get BE. And BE is going to be, when we take 10 squared and we add 5 squared, then we obtain the square root. Then we obtain the square root. So 5 squared plus 10 squared. Then we obtain the square root. We're going to get 11.2. Remember, we want it in one decimal place. The other thing we are told to calculate is, in part B, the angle between BE and the plane ABCD. BE, the line we've just calculated, to be 11.2. So the angle between this line and the base ABCD. So a line and a base, or a line and a plane, the angle between them is determined by when we get the angle between the line and its own projection on the said face. Therefore, we'll have the projection of BE on the base and they will give us this angle. So we want this angle, and the value of this angle will give us the angle between the line BE and the plane ABCD. Therefore, that angle can be calculated using any trigonometric ratio, given that we already have all the sides. So we can say the tangent of this angle, for instance, if we apply to use tan, the tan of the unknown angle will be equal to the opposite, which is 5, out of the adjacent, which is 10. And now we can say that theta is going to be the tan inverse of 5 out of 10. And this angle is going to be the tan inverse of 5 out of 10. This is going to be 26.6 degrees. Remember, it is to one decimal place. The other thing we are told to calculate, it is on the next page, whereby we are told to determine the angle between FH and BC. FH and BC. FH and BC. So FH and BC, FH and BC, these are two lines, the angle between them. FH is a line here. FH is the diagonal in the upper plane. This is our FH. You can produce the line. That is FH. We want the angle between FH and BC. And now BC is a line at the base. So what we do is that we do what we call translation of lines, whereby a line has to be translated to the plane having the other line. For instance, here, BC can be translated to the line where FH is, and on that plane, BC will become GH. Therefore, we just want the angle between FH and GH instead of BC. So we translate BC to GH. Therefore, we want the angle between these two planes. Remember, this is 6. Remember, this one is 8. And again, this one is right angled, given that the faces are rectangular. Therefore, from that point now, we can get the angle at that point, whereby we can use, again, tangent. The tan of that unknown angle is going to be, the tangent of an angle is opposite, so 8, out of adjacent, 6. This means the angle itself now, the angle itself, theta, is going to be the tan inverse of 8 over 6. And to one decimal place, we are going to get the tan inverse of 8 over 6. This is giving me 53.1. 53.1 degrees. That is going to be the angle. The other question which follows is the angle between the angle between FH and BD. 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 So FH is here, but BD, let me get BD, but BD is at the base. So again, we're going to do translation because we just have to translate the lines so that they may be on the same plane. So FH is on the top, but BD is at the base. So we can drop FH, and translating FH, it will become AC. FH will become AC. FH is going to become AC. So instead of FH, we use AC. And now at this point, we can get now the desired angle. So what we want is now the angle between AC and BD. So instead of FH, between AC and BD. And this is going to be the angle. This is going to be the angle. Therefore, we can first calculate the angle here. Can first of all determine the angle here. And we also determine the angle at the other point here. Then we subtract those two angles from 360. From 360. Therefore, we're going to start with the angle here. When we have 6, and we also have BC here, which is 6. This is 8, sorry. So we're going to apply tangent, whereby we say the tan of this angle here, the angle at A, is going to be 6 out of 8. 6 out of 8, which means that the angle itself is going to be the tan inverse of 6 over 8. And this angle is going to be shift tangent 6 out of 8. This is giving me 36.9. 36.9 degrees. So this angle is already known to be 36.9. After that, we can get the angle here, the angle at this point, whereby we're going to use remember we have the length of 8, we have the length of 10, and we have the length of 6, which means at this right angle here, at that right angle there, we can use 6 and 10 or with 8 to obtain the other angle here. So the angle at this point will be calculated by, we can again apply tangent, whereby we will say the tan of the angle at B is going to be, the tangent of this angle is going to be the opposite, which is 6, divided by 10, which is the adjacent side. Therefore, the angle at B is going to be the tan inverse of 6 over 10, and the tan inverse of 6 over 10 is going to be 30.96. So to 1 decimal place, it would be 31.0. Therefore, with the angle here is 31 and the angle here is 36.9, we can get the angle we wanted now. The angle between AC and BD. The angle between AC and BD, which is going to be 180 minus 31 and 36.9. Therefore, when I take 180 and I subtract 31 and 36.9, I'm getting 112.1 degrees. Thank you for following. Subscribe and share.